given grid. So you will be given a grid. So let's take the grid is something like this. You will be given a grid called 1 0 1 0 0 and 0 1 1 1, sorry, 0 0, right, 1 0 1 1 1 and all ones, then 1 double 0 1 0. So these are the grids. This is the grid which was given. So we need to find out max rectangular, right? If you closely see here, how many rectangles we could make. So this is one rectangle, correct? Yes or nobody? This is one rectangle, and this rectangle length was, if you closely see, the area of this rectangle is definitely 4, so that you got 4. 1 is 4. Let me highlight. So this is one rectangle. Okay, so we got 1 is 4, and let's look at other rectangular. You could see this is one more rectangle. So definitely this is one more rectangle. So here the length, the area of the rectangular is 3, and we do have one more rectangle, this one. So this is one more rectangle. So the area of this rectangle is 6. So we just need to have 6 here. Then if you closely see, we do have this one. So this is one more rectangle, so which is 5 and which is 3, so something like that. So this is one more rectangle, so which is 5. So we also have 5. And if you closely see, there are some individual rectangles. So if you closely see, this is 3, this is also 3, and somewhere you couldn't find individual rectangle, yeah, so this is 2, something like that. So there are multiple rectangles you could see, but the max rectangular area you could form here is 6, so we need to return 6. That's the expected output. Is this clear? The problem statement is clear. So this is the maximum rectangle, so which is the area having 6, so that is to be returned. Is the problem statement clear? Okay, so please raise up your hand if you are having a doubt. Okay, so if you are not raising a hand means you understood. Okay, now how do you solve it? How do you solve it? So that's a tricky part, right? So this problem, uh, let's divide this. So I'll give you a, what do you say, let's see the thought process here. So you have a grid, and if you want to tackle this problem, right, with brute force, it is very complex. You can't even think of brute force. Let me give you one idea. uh, let's say let's consider only one row. So let's say you have only one row. If you are having only one row, then it is how it is, it should be 1 0 1 0 0, right? So let's say you have only one row. So if you are having one row, so it is having the value as 1 0 1 0 0. So it means something like this, right? So you have 1 and then 0, then again 1. So this is 0 and again 1 and again 0 and again 0. Now if you have single row, now what could be the maximum area you could get here? Maximum rectangle area you could get here? 1, right? Yes or no? So either this one or this one, right? So with respect to this row, so you can't even make this. So definitely it is 1. So obviously the expected answer here that could be 1. Okay, now let's say you have two rows. Let's say I'm having two rows. So let me erase this. So I'm having one more row, and the second row is having 1 0 1 1 1. Okay, so I'm having two rows. Now what I'm trying to do is, let me try to calculate, let me convert these two rows into single row. How do I do that? So let's take what is the length of this, what is the height of this row, obviously which is 2, height of this row which is 0, height of this row is 2, because 1 plus 1, right? If you closely see, this is the height, right? So this is the height. So 1 plus 1, so which is going to be 2. So let's calculate the other one, the height of this row, so which is 1, and height of this row, which is 1. Now somehow I find out height of the two rows. Now if you go, if I tackle this row, so if I try to find out a max rectangle with this, let's see what it could be. Did I do any mistake? No mistake, right? Okay, so let's see what it could be. Yeah, perfect. So you have 1 is 2 height with height 2. Okay, so I have height 2, then you have height 0, then again you have height 2, then again you have height 1, then again you have height 1. So what is the maximum area you could make here? What is the max area you could make here?
2.
Can you think little bit? Is it 2? Max rectangular you could make. This is the maximum rectangular I could make, right?
3, yes, 3. Yes, yes.
Definitely 3, right? Do you see any pattern here?
Yes.
Do you see any pattern here? This is yesterday's problem only,
Yes.
na?
Yesterday's problem.
Yesterday's
Yes.
problem only, na? So longest histogram, right? So longest histogram. Okay, so I will give you. Okay, so now somehow if you figure out what is the height of the combined rows, let's take one more row. Okay, so let me erase it. So as of now I got value as 3. Let's take one more row. If I take one more row, so you will get something like this, right? So I'll have 1 1 1 1 1. Okay, so let's move on. So if you go 1 1 1, somehow if you find out the prefix sum, so here it is 3, here it is 1, here it is 3, here it is 2, here it is 2. Now let's move further. So this is what you got, right? So one is with length with height 3. So one is with height 3, other is with height 1, then again height 3, then again height 2, then again height 2. Okay, this is 3 2 2. So what is the max area you could make here? So let me 5. So I think you are saying this one, right?
Yeah.
So this is 5. But if I start from here, how much it will give? If I start from here, how much it will give? 6, right?
6. Yeah.
So there are possible things. One is you can make complete extension here. So this is going to be 5. But if I try this area, and this is definitely 6, right? So this is definitely 6. So that obviously I got 6 here. Now if you closely see with 3 rows, you got the max area as 6. So this is the 6. So obviously you got 6, right? But how do you find out this, right? So finding out a max area in constant time. You want to find out. So assume that this is 0, 1, 2, 3, 4. Let's say these are the indexes. So how did we find out this? Let me revisit the algorithm so that we can reuse the same problem and somehow we can solve it. Okay, let me. So this is a concept we used, right? So what we did. So let's say I'm at this bar. I'm at this bar. If I'm at this bar, what is the maximum rectangular I could make starting from this bar, right? So in this case, if you closely see, this bar cannot be extended right, because if you want to extend it to the right, so the next bar should be higher than this, right? So what is the, so for example, you want to find out a max rectangular you could make from this bar. So how do you know that? So from this bar, what you did, so you can able to extend till here, and somehow you find out this is the area you could make. So definitely you got 6. But if I am starting from here, from this bar, what is the max rectangular area I could make? This bar can be extended to the right at last, can be extended to the left, so that the total area you could cover is 1 2 3 4 5. So the current bar height is 1, and this one can be extended complete right, can be extended complete left, so that 1 2 3 4 5, so that you got 5 into 1, so which is going to be 5. So when it comes to this bar, right, when it comes to this bar, if you closely see, this bar can be extended to the left till here, can be extended to the right till here. Now this is the total area you could make. So total you have 3 into bar height is 2, so 3 into 2, which is going to be 6. How do you know that this bar can be extended to the complete right and this bar can be extended to till here? How do you know that? Please. I am at this bar, right? How do you know that you can extend till here and you can extend till here? I cannot extend furthermore, right? So if I cannot, this bar cannot extend it after when I come to left, I can come till index 2, I cannot extend to that index 1. So how do you know that?
If it's greater than the current.
Perfect, right? So generally you pick up any bar. So you pick up any bar. So let's pick up this bar. Okay. So what we are trying to do for this bar, we need to find out what could be the previous smallest index value. Okay. So it means you can extend this bar till here, right? So I can extend this bar. So I can extend this bar till here. I cannot extend after that, right? Because if you closely see, with respect to bar index 3, you have a bar height as 2. So we need to find out till where I can extend. So that I will find out a smallest value compared to this. So this value is 2. The smallest value compared to this is 1, which is at index 1. Okay, so which is at index 1. And similarly to this bar, what is the next smallest value? So generally what are you trying to do? So you are trying to extend the bar until you find a smallest value to the previous, smallest value to the next. So if you see I'm here, the next smallest bar I didn't find anything, so I can extend till the end. So that definitely the next smallest index is going to be, obviously you can extend till 4, right? So you can extend till 4. It means that 4 is the last index. So you can definitely take the you can extend at the end. So the end is representing length. So here the index is 4, right? So length is going to be 5. So definitely, so it means what I'm trying to say is the algorithm is simple. So you can pick up any index, find out what is the next previous, what is the previous smallest index, what is the next smallest index. So in this case, with respect to index 3, you have bar 2. So go left, find a bar which is having the value less than 2. So this is having less than 2. It means I can extend till here. So before one index I can extend. Similarly from this index you can find a bar to the right which is having less than this 2. So but when I go right, there is no bar, so definitely which is going to be length of the array. So it means you are extending till 4. So simple. How do you know that the calculation is, next you need to find out the length of this. So what do you say, how many units you can consider. So once you find out a index, so the principle is next smallest index minus previous smallest index minus 1. So in this case, next smallest index is 5, previous smallest index is 1 and minus 1, so which is going to be 3. It means you can extend till 3 units. So this is what I am trying to say. So you find next smallest index and previous smallest index, and this is a principle. You can get the total area into the height of the bar, which is 2, so which is going to be 6. So this is the conceptual understanding. So this is what, how do you calculate, how do you find out this next smallest and previous smallest index in constant time. So that's a tricky part. For each index what we should do, so we need to find out next smallest index and previous smallest index, and for a given index, so once you find that area into that given index value, you got a max area and you keep on updating the max area. So finding out this next smallest index and previous smallest index for each index is the tricky part. So you can find in constant time on an average. Just a second. Yeah, so you can find in constant time. So that's what we did yesterday. So you can use stat. You can now, with this concept, you can revisit the previous problem. You can understand. Similarly, if I pick up this one, right? So let me give you a couple of examples. If I pick up this bar, I cannot, next to smallest index for this is 1 itself, because you know to the right you have an immediate value. So that if I pick up at 0th index, at zeroth index you have bar height as 3. So next to smallest index is 1, because 1 is the smallest value compared to 3. And previous smallest index, there is no previous to this, right? So definitely you can consider it as -1 just to satisfy this principle. So that principle is 1 minus of -1, because this is what, right? Next smallest index, previous smallest index, 1 minus and -1 and -1, so which is going to be 1. So you got width as 1, so 1 into the value is 3, so definitely you will get 3. Similarly, if I go to index 1 and you have value 1. Now if you closely see, if I go to previous smallest index and there is no previous, so when you go left, so all are greater than this, so definitely you will go behind 0, so that for 1 the previous smallest index is going to be behind 0, which is -1, and next smallest index, definitely you can extend this one, you can extend this one to the complete right, so definitely you can extend to the complete right. So when you're able to do that, so the next smallest index is going to be length of a array, in this case which is 5. Then the principle is 5 minus -1 -1, so which is going to be how much, buddy? Yeah, so which is going to be 5 again. So 5 into height of this bar, which is 1, so that it is going to be 5. So definitely you could find from this bar you can find the longest triangle as 5, but when it comes to here, so you can find the longest triangle as 6, so that somehow you found 6 is the max area. So this is the concept. The only tricky part is how do you make sure that you can find out next smallest and previous smallest indexes in constant time. So that's what we implemented through stack. So somehow if you know the bars, then if you are able to find out if you are able to construct a height of each, so you will have couple of rows, and for each row you will see the possibility, and whenever you find a maximum area you can update that max area. Then it's a simple thing to solve. Now let's move on. You have 3 bars. Now let's go for fourth bar. So now let's go for fourth bar. So you have 1 0 0 1 0. Now this is where so while constructing the row, right, so this is where you need to keep a little bit observation. So in this case you have 4 ones 4, but in this case you have 1 1, right? It should not be 1, because it is starting with 0, right? If the current bar height is starting with 0, don't consider previous ones, so obviously which is going to be 0. And even in this case also current bar is, because we are trying to find out for fourth row, so this is going to represent fourth row, so this is current bar starting from 0, so that definitely it is going to be 0. And in this case current bar starting from 1, so definitely you can take it, so which is 3. And this is going to be again 0, because the current bar height is starting from 0, so which is going to be 0. So that's it. So 4, then you have 0 0, then 3, then again 0. Now this is what you have. So what is the longest triangle you could make, rectangle you could make here, please? What could be, buddy? 4 only, right? Yes or no, buddy?
Yes.
4 only, right? If you closely see the diagram, this is what you could make. You can't even make or you can make 3. So either you get 3 or you get 4. So obviously which is 4, but you already have max area as 6, so the 6 will be written. Did you understand? So what we are trying to do, somehow we were able to figure out prefix sum of each row. Prefix sum of each row. What's happening? Somehow we should able to figure out some problem with the charger. Okay. Somehow we should able to figure out prefix sum of each row. Then you can find out. The max area for each row. Then you can hold what is giving the max. So that is going to be your answer. right? So now how do you construct a prefix sum from a given? So once you are able to construct a prefix sum for each row by considering the columns, that's it. You can easily find out longest rectangle you could make with the previous concept. Correct na? Correct na? Ajay, Kalyan, Maithili, Akash.
Yes.
Right, so now let me take this input. Let me take this input again. So definitely I'll simply copy this. Okay, so let's move on. So let me construct a prefix array for this. So prefix sum. So it's a concept of prefix sum, simple. So for the first row, there is no change. So whatever it is, which is how it is. Now in the second row, definitely these two will be added. So it is going to be 2, 0. Then again these two will be added. So this is going to be 2, and you have only 1. And here also you have only 1. So 1 will be done. And to the third row, and these 3 will be added. So which is going to be 3, and definitely it is starting with 1. So 1. Again you will have 3. Again you will have 2, 2. So definitely 2, 2. To the fourth row, so definitely you will consider all these 4, and
1.
no 1, right? Because it is starting with 0. So when the
Okay.
bar is starting with 0, blindly consider it as 0. Again for this also, which is 0. And again this is 3. And again this is 0. Right? So what is the time complexity to construct prefix sum array or prefix sum grid? Please.
It's n square.
So let's say length is row size is there are rows, right? So number of rows equal to m, and number of columns is equal to n. Then it is going to be m cross n, right? But you have to write an intelligent algorithm. You have to write an intelligent algorithm in order to make this concept, this prefix sum as m cross n. So we will write it. Okay, so we will write it. And once you find it out, and for each row, so this is rows, right? So let's consider for each row, so you have m rows, right? You have m rows, and for each row you need to find out what could be the longest rectangular you could make, right? So definitely you will have for each row, how many columns you have? N columns, right? Yes, please. Yes or nobody? For each row you will have n columns, right? So it means you have n size array. You have n size array to find out longest rectangular. So what is the time complexity? We already solved it, right, yesterday? Yes, sir. We already solved it, right? So if you have length array of size n to find out longest rectangular, so what is the time complexity for this? It is linear, right?
The linear, yes.
Right, so it means first you will construct a prefix sum. And why? Because if I already told you, right? So for each index you can find previous smallest index, next smallest index in a constant time. Then if you are n indexes, finding out previous and smallest is going to be constant time. Then once you find this out, then you can find out this value in constant time. So it is going to be linear only. So you can solve this problem in linear. So once you are able to solve that in linear, so because you have m rows, so definitely which is going to be m into big O of actually 2n, because we are using stack. So in worst case each element can be visited twice, so which is going to be 2n. So which is something like so big O of 2m n. So but you can consider it as mn. So for prefix sum and for longest triangle, so the rectangle, so this is what the time complexity. Correct, nobody? Maitri, is it clear for you? Yeah. So once you find a time complexity, so what is the space complexity now? What is the space complexity now? What are we using? This is grid, right? So this grid we are using now. Yes or nobody? Yes or no?
Yes.
So this grid we are using, so
Yes.
which is going to be mn. Plus, we are also using stack now. We are also using stack, and closely understand the stack size at max. You will have n size. So n is representing column size, right? So for each row, you initiate the call separately, so that it's not parallel call, right? So for each row, we are trying to solve the problem separately. So mn plus n. So obviously, which is going to be mn. So is the space complexity is clear? So this is for prefix sum and this is for stack. Correct, nobody? Any
So the
question?
system what we calculated here will pass it to calculate the largest rectangle.
Yes, yes. So we did it for separately, right? So while going through algorithm, so we did it for each row separately, right? Yes.
Yeah.
So
Okay.
that's what we try to do. So let's implement this. Right, trust me, buddy. You know this concept, right? You know this concept. This concept uh, finding out prefix sum in a given matrix. So I got this problem on Google interview. It was very deciding round, and he was given very hard problem, and through some line sweep concept, I was able to solve that in 7 minutes. Then so he was a little surprised, and he come up with a follow-up question, and which is really tricky. uh, so what happened while before getting into the code, in my mind I have the complete algorithm, but it has to use a matrix with prefix sum concept. So some so prefix sum concept. So before getting writing the code, that was in my mind. Somehow what I did while implementing the code, I forgot that concept, so I should use prefix sum. Then I have written the code. It was really lengthier problem, so definitely it took around 20 minutes to write the code. And initially he also thought that I have written a valid code, and when I am doing dry run, right, then I understand when I am doing dry run, which is not even passing for the basic test case which was provided for the follow-up question, then then there is no time, so it's 45 minutes, right? So already it took around 38th minute I finished the code, and it took 5 minutes for dry run. Then I have left with 2 minutes, and within 2 minutes I should apply this prefix sum concept, and I was not much handy on this pattern. Then I couldn't able to catch the bug and apply this concept. Then somehow I got some negative feedback on that wrong. So that's how it is. So what I'm trying to say is, when you are giving interview, right? So definitely before writing the code, you write the algorithm. At least the tough parts you write on that note. Then while writing the code, so you just revisit it. Generally, what happens when you trying to solve the complex problem, and that too in an interview pressure, definitely you tend to miss what you want to implement. So that's a blunder I did. So don't do that. Okay, so let's implement this. So I have yum, which is going to be matrix dot length n, so which is going to be matrix of 0 dot length. So now what is our job? So we need to find out prefix sum for each for this matrix. So new integer of yum n. Okay, now let's move on. Yeah, so you have row less than yum, row plus plus, and for column less than n, column plus plus. Okay, so what is our job now? So let's see if the given matrix row column, whatever you see, if given matrix row column, if it is equal to 0, so he has given in the form of character array, so that's why I am just comparing with 0. If it is 0, then definitely the prefix sum of current row column definitely it is going to be 0, no doubt about it, because you cannot add previous values. Else else what we should do, so what we should do, so this is going to be previous prefix sum of row column, right? So what we should do, so 1 plus whatever you have in the previous row for the same column, just take that
Row
value.
minus 1, column minus
Column, same column, right? Not column minus 1. So you just move on to previous row, take that value. But only tricky part is if it is the current row, right? So consider only if it is row greater than 0, then only you will have a previous row. Otherwise, what you do, so you will take the, you will just return it 0. Clear, buddy? Understood? Or let me write it. This is not complex logic, don't get confused. If row greater than 0, it means if you are trying to find out for second row, then take the previous row value present in the same column. So it means previous row value present in the same column, add plus 1. Otherwise, you just take 1, because obviously it is 1, right? So if it is the same row, you just take 1. Clear, buddy? Ajay, Maithili, Kalyan.
Yes, understood. Why? Actually, we are updating the second row only, right? We can.
No, for every row we should calculate, right? So this prefix array contains all the rows height, right? Once you're done with it, then what is our job? We need to find out max area for every row, right? So simple. So what you do, this is my max area, which is going to be 0. So what is our job? So first you take row starting from 0 and row less than m, because you have m rows, and row plus plus. So what you do? So what you do? So you will get integer array of current row. Current row you can have prefix sum of row. So once you get this current row, so what is your job? So you will call get largest rectangular, passing this current row, and you will get the area, right? So you will get the area, compare with this max area. So max area equal to math dot max of max area comma get largest rectangular. Done. So finally you will return this max area. So let me copy this largest rectangular from previous problem. I don't want to write the code or explain for it. It will kill our time. So this is the code we have, right? So let me copy this.
Actually, we can store that prefix sum in single dimensional array only, right? So anyway, we are updating the column. So when you explain that.
Just a minute. Let me run this and I'll address your doubt. Okay, done. So that's it. Hope this is clear, right? Others?
Yes.
Ajay, Maithili. What's happening? Current row spelling wrong, right? So that's it, buddy. So that's the crux of it. Yeah, now let's move on. What's your question? So why to go with complete prefix sum? So rather than that, so this is what the improvement you are trying to say, right? You hardly have max
You
m.
can take
Yeah.
max, right? N. So because that is a column, right? Max.
Yeah, so this is good improvement. So what he's trying to say is each time you will find out prefix sum. So definitely what it is going to do. Yeah.
You can
So yeah. Do you understand? So at any point in time, we just need to know previous row, right? Yes or nobody? We just need to know previous row, right?
Yes.
Others, please. So you don't have to maintain m by n grid. You can come up with single grid of length column, and closely see. I will just remove. So if it is 0, then max of column you can blindly make it as 0. Otherwise, max this prefix sum of column, whatever prefix sum of column, what you can do, so you can simply say, uh, yeah, so you can simply say, is this
Column plus 1.
column plus 1? So whatever this is representing previous row only, na? So this is representing previous row only. So to the previous row, so you can add plus 1, so which is going to be that. Now for the by this time you will get the current row prefix sum. So once you get it, definitely you can simply apply, you can simply pass this prefix sum array and find out a max area. So that's how you can improve the time complexity and multi-iteration. So it's a optimized code. You give a try. I didn't explain it completely, but you give a try. So let me run it. It's a better way to address it. Hope you understood, right,
Yes.
Ajay? Maithili, is that clear?
Yes, sir.
Yeah. So it's a better way of improving the space complexity. Good idea. Okay, so that's it. So please give a try. Let's move on. Yeah. So this is very interesting problem. So we need to find out next greater element, but this is going to be circular array. Okay, so this is going to be circular array. So that's what he's trying to find out. Given a circular integer array, we need to find out next greater element. So let me take an input, then we will get into that. Somehow this got stuck. Let's see how it reacts. Yeah, so problem number is 503. Okay, so let's say you have 1, 2, 3, and 2, 1. Okay, this is the array. We need to find out next greater element for each and every index, but this is a circular array. So that's the tricky part. So as of now, whatever you solved, which are not, that is not circular array. Assume this is going to be circular array. For example, in the earlier case, for 1 there is no next greater element because that was not circular array, but this is a circular array, right? So definitely you can find next greater element as 2. Is that clear? Is that clear, buddy? For 1 it is a circular array, right? So you can find out value as 2. So definitely I'll get value for 1 which is going to be 2. For 2, what is the next greater element, please? So definitely this is not. Definitely you will go here and it is going to be 3, correct?
Yes.
Because it is a circular array.
Yes.
So which is 3. For 3, do you see any next greater element? So let's move on. So I don't
No.
find any next greater element. So definitely it is going to be minus 1. So definitely it is going to be minus 1. And similarly for 2, you have next greater element immediately, so which is going to be 3. And for 1, the immediate one is the 2. So this is what expected answer. So hope the problem statement is clear, right? Correct, na?
Yes.
Yeah. Now how do you solve it, right? So this is very conceptual way of writing the code. So this is not tough problem. If you know how to tweak it, let's move on. So what I will do, so this is my array, right? So my array is 1, 2, 3, 2, 1, which is having 0, 1, 2, 3, 4. Okay. What I am trying to do, I duplicate this array. I will duplicate this array. So once I duplicate this array, so how it is going to be? So you will have same array again. So which is of length 1, 2, 3, 2, 1. So this is my duplicated array. But actually I don't do it. Actually I don't do that in code. I don't do that in code, but logically I will break it. So definitely again I will duplicate this array. So which is going to be 1, 2, 3, 0, 1. So actually that's how it should be. So if I do that, so this is going to be a index 5, 6, 7, 8, 9. So But actually I didn't do that. I didn't duplicate it, but somehow I will able to handle through coding. Let's see if I am able to somehow do it. If I am able to somehow do it, then definitely what is the next greater element for 1? Let me do that. So if I am at here, what is the next greater element? I can easily find as 2, right?
Yeah.
Correct, nobody? Ajay, Maithili, Kalyan.
Yes.
So for 1, so which is going to be 2. Okay, perfect. So for 2, what is the next greater element? So which is going to be 3. And for 3, the next greater element. Now how do you know that? So I am at 3, right? I am at 3. So which is at index 2? Which is at index 2?
I didn't understand why are we duplicating. Can you please come again once?
We
If you
need to
don't
traverse.
duplicate it, then how do you traverse? It's a circular array, right?
Correct.
So if it is a circular array, if you don't duplicate it, how do you find out next greater element for 1?
Okay. Yeah, got it.
So the tricky part is closely understand. You are at index 4, right? So you are at index 4. Okay, so somehow I am at index 4. It means I'm already having one element, and I will consider next 4 elements, because the length of the array is 5. So I will consider next 4 elements, and it means I will consider this part and find out a next greater element, so which is going to be 2. Okay. Now I am at 2, and it means I am at index 3. It means I have 2 elements, so I will consider next 3 elements in the array, so that if I consider this part, this is going to be my final array. The next greater element is going to be 3. Now I am at index 2. It means I am having 3 elements. If I am having 3 elements, then I will consider next 2 elements in the extended part. So if I do that, so this is my array, and there are no next greater element for 3, so that obviously which is going to be minus 1. Now when I am at 2, so I will consider next 4 elements, and definitely which is going to be 3. And when I am at 1, so I will consider next 4 elements, so I don't need to worry about this. So definitely which is going to be 2. Do you understand the concept what I'm trying to tell? Let's derive
Yes.
how to do that. Let's derive how to do that. So closely understand, I don't take this duplicate array, but still I can able to replicate. How do I do that? So what my concept is talking about, you must and should take 2n array. Correct, nobody?
Yes.
You must and to take 2n size. 2n size, but 2n size. So starting from 0th index to 2n minus 1. Correct, na? So 2n, this is what the index is, right? Correct?
Yeah.
Yes.
So 2n minus 1. Okay. Now closely understand. So I have 9, right? So this 9, you have value 1, which is representing index 4, right? Yes or no?
Yes.
Ninth index, value 1, which is representing this 4th index. If you closely see, 2n minus 1 means what, buddy? 9 only. 9 percentile by n is 5, so which is equal to 4 only, na? Yes or no?
Yes.
Similarly, you have index 8, value 2, which is representing this one. So it means 2n minus 2 is going to be the 8 percentile by 5, so which is going to be 2. Correct, na? Correct? Sorry, which 8 percentile by 5, so which is 3, so which is representing this index. Nothing but this only, na? Yes or no?
Yes.
Yeah. Now let's apply the stack concept. Let's apply the stack concept. Then we will see. So when do you track the result? So when do you track the result? So when you are processing these elements, don't do anything. And when you are starting from here, then hold the results. So results are, our results length is going to be this one, right? So which is going to be something like this, right? So 0, 1, 2, 3, 4. So this is our result array. Okay, so this is our result array. Now when you are here, right, so obviously you start from 2n minus 1, and you will move until 0. But when do you capture the result? So when you are at from index 4 onwards, you will load that whatever result you get, you keep that result into the result array. So let's do that, so things will get clarified. So first I am at index 9. So because I start from 2n minus 1, right? But I don't have 9th index, but I can simply say that 9 percentile by 5, so which is going to be 4. It means at index 4 I have value 4, and initially stack is empty, and I'll just keep that. Okay, so as the current index is 9, so I don't update here. Now let's move on. I'll move on to index 8. Obviously I'll get this value. So 8 percentile by means this 2 is greater than 1. So you know next greater element means you can blindly ignore this. Again blindly you can keep 2. So that you already know, right? Because the current element 2 which is greater than stack dot stack last element, so that you can delete. You want to find out next greater element, so that if it is smaller you can delete it. Now previously when you go to 7th, definitely you will be here, and 3 is greater than 2, so that you can delete this. 3 keep. Then when you move on to 2, and 2, now you understand, so you are at index 6. So you are at index 6. 2 is smaller than 2 is smaller than top value 3, so definitely you will keep 2 here. So when it is smaller you will just keep it. So that's what we did it, right? So you are now, you will go to index 4. Now at index 4, so definitely you are at index 4, right? So that's how it is, right? So 8 9 8 7 5 6 4. So when you are at index 4, then 4 percentile by 5, so which is going to be index 4. So again this is what it is representing 4. Now you have value 1. So 1 1 is less than the top value, right? So 1 is less than the top value, so definitely you will consider the next greater element for 1, which is going to be 2. So because you can blindly take this, and you are at current index 4, right? So which is representing the result index. So it means from 4 onwards you will capture the result. So whatever result you get, so you take that result into here. So top value is 2, which is greater than the current element. So this is means you take that 2 here. In the stack you have 2 3, then you will add current element 1. Now you will move on to next previous index. 3 percentile by 3 5 means again you will get this. 2 is not greater than in the stack you have, yeah. So now you compare with stack. So this is 2, right? So 2 is greater than top value, so delete it, and this is also greater than or equal to top value, delete it. Now you have 3 in the stack, so which is greater than 2, so consider this 3 into the result, again take 2. Now previous, again you go minus, definitely you will go to index 2. Now at index 2 you have value 3. Now when you compare with 2, which is greater, when you compare with 3, which is also greater, now stack becomes empty, so obviously you will store minus 1 here, and you will load 3 here. Now when you go to previous index you get value 2. 2 is less than 3, so definitely you consider 3, and 2 will be loaded. And when you go here, 1 is less than the 2, so definitely you will keep 2. And when you go further, so which is going to be minus 1, so you are done with the result array. Is this clear, buddy? I went very fast because we already discussed a couple of times, or did I made you confused? Ajay, Kalyan, is this clear or confused?
Confused, you know.
Confused.
A bit. Like
Alright,
that.
then if I am really going without your understanding, right, you could have paused me, na? Anyhow, I need to re-explain, right? So that will save my time. So let me do that. So what I'm trying to say is, you have 1 2 3 2 1, which is having 0 1 2 3 4. This is the index we are trying to address, right? So conceptually what I did, so when you say conceptually what I did, so I will consider I will try to duplicate this to 1 2 3 2 1. So when I am at this index, so I will consider next 4 elements, right? So these are the next 4 elements. When I am at this index, I will consider this 4 elements, next 3 elements. When I am this index, I will consider till here. I am here, so when I will consider this here, I am here, so I can blindly consider this part. So that's how conceptually we thought, right? So what we did, so definitely we don't duplicate this array, but somehow to address the circular list, we will start from 2n minus 1, so 7 8 9. So index is starting from 2n minus 1, so which is going to be 9. Okay, but there is no 9th index here, so there is no 9th index here, but you need to find out this 9 index is pointing to this value. How do you know that? 9 percentile by length of this array, so which is going to be 4, so it means which is pointing to this value. Till now it's clear, no?
Yes.
So now your stack is
Yes.
empty, right? So that definitely you will have value 1. Now what is the next index is going to be 8. So definitely 8 percentile by 5, so which is 3. So definitely this is pointing to this. Now the current value 2, which is already greater than the value present in stack, it means you didn't find greater element, so that you will delete this and add value 2. Till now it's clear, right?
Yes.
Because you want to find out next greater element.
Yes.
Now I am at index 7. 7 is representing index 2 only, so that index 2 you have value 3. Now in the stack you have value 2, right? But the current element is greater than 2, so definitely you will delete this and keep 3. Now again I let index 6, so which is representing index 1. 2 is smaller than 3. So definitely in the stack you have 2, but do I need to capture 2 or not? So 2 is smaller than 3, so that you will keep 2 here. Because we will get to know, because when do you hold the result? So when you are starting from index 4, so till now just hold the result. Now you are at index 5, so it is representing 0, because 5% L by 5, which is going to 0. Now if you closely see, 1 is smaller than top value, so that 1 also will be holded in the stack. Now this is our time. So we have a stack with values 3, 2, 1. So this is what the stack contains. Now I am at index 4. So this is what I am trying to do. Now if you closely see, right, if you closely see, from index 4, I need to consider next greater element. So that's why what you do, so whenever your index is less than n, then it's time for you to capture the result. So it means you have a result array of size same length n, so which is 0, 1, 2, 3, 4. So it means you are at index 4. So it means for 1, what is the next greater element you need to see? So if you closely see, this 1 is representing index 0, this 2 is representing index 1, this 3 is representing index 2. Of course it needs to cover this 3 as well, but the 2 is already present, that's why we just ignore. Actually from here we need to consider next 4 elements, right? So of course it has to consider this 2 as well, but we deleted it because we already have 2 here. So that's why the stack is, that's a concept of monotonic behavior. I am at here, this one is representing index 0. Hope you understood, right? This part is understand, no?
Yeah.
So,
Yes.
so this one is taken from this, right? So this one is representing, this is representing 1, this is representing 2. Now it's time for us to, I'm at index 4, I want to find out next greater element. Index 4 you have 1, in the top you have 1, so that I can delete it, because this is smallest element, so that I can delete this. Okay, so let me delete that. Then I'll have next element is 2. Okay, 2 is greater than 1, so definitely I can take 2 here, correct? Yes or nobody?
Yes.
So I can take 2 here. If you closely
Yes.
see, okay, what's happening? She is unable to join. Why it is happening? Maithili, you are unable to join, is it? Maithili, you are on mute. Okay.
When we leave the meeting somehow by power cut or internet issues, it will ask for admit again.
Yeah, that's a problem. Okay, I'll look into that. Okay, so now it means now you are moving on to previous index, right? So when you are moving on to previous index, store the current value 1, which is representing index 4. Okay, is that clear? Is that clear,
Yep.
buddy? So actually you got confused here only. So if this part is clear, then
Yes.
so this is already done. Now I am at index, if I go to previous index, so which is going to be index 3. So now I need to store that result. At index 3 you have value 2, right? Now remove this one. So 1 is less than 2, and 2 was also less than or equal to 2. So then you can delete. So definitely you have value 3. Okay, nice. So when you consider 2, if you closely see, when you consider 2, this is going to be the highest value, because we are trying to track this part, right? So from 2 we are trying to track this part, so that's why somehow we were holding that 3 here. So that's why you were able to find out 3 is the next greater element for 2, so that you can blindly take that 3. Is this clear? Is this
Yes.
clear?
Yes, clear.
Now we can delete this part. So now when you are moving on to previous index, store the current value, so which is 2, and which is at index 3. Now let's move on to previous index. Now I move on to index 2. At index 2 you have value 3. Now if you closely see, this is what we holded, right? So value 3, actually it has to consider till here, but of course it is holding this value also. Anyhow it is always going to be deleted, because the current value is always equal to this, so it will be deleted from the queue, so that don't worry about it. Okay, so now what is I'm trying to do? So I'm at index 2, I have value 3. So but in the stack you have values which is less than the current index, so that I can blindly delete these values. So once I delete these values less than or equal to current value, so the stack becomes empty. Now the stack is empty, so that you can directly load -1, and before moving on to index 1, load the current value 3 which is at index 2. Now at index 1 we have value 2 which is smaller than this. Blindly you can take that and store that index 1 value. And let's move on to yeah, so we are at index 1, we are done with index 1. Let's move on to index 0. At index 0 we have value 1 which is less than the top value. Take that value and keep the index 0 value, move further. And if you move further, so you are into -1. So when you are in -1 you can end it, and this is your result array. You can simply return the result array. Clear, buddy? Okay, just a minute. Unable to understand, right? Please let me know so that we can save the time. So let me write the code. So now what is the time complexity here? What is the time complexity here?
Order of 2n.
Yes.
2n.
Order of 2n. So what is the space complexity?
We are not taking any additional space, only the stack we are
Stack
using.
and result, right? So result array is
Yeah.
going to be order of n. So and what is the stack
Just
space?
2n.
Can you please think?
Actually, do we really need the additional array? Can't
Because we
we
need to
operate on
return the
existing?
result, right?
You have to
Okay.
If you
Okay,
update the
okay.
same array, then it will. What
Okay.
is the space
Order.
of stack now?
It is also 2n because we are removing
Can you think? Can
the
you think?
elements.
Can you think?
No, at max it can actually hold all the elements.
How many elements we
Stack.
have?
Order of n.
N elements only, right? This
Yeah.
part is imaginary. This part is imaginary, right?
Correct.
So the other part,
Yeah.
is there any lag?
Yeah. Understood. Yeah.
No, there is no lag.
No lag.
Okay, so that part is imaginary. So definitely, this is going to be N only. Okay, so let me
N.
write it. So if you write the code, you feel like it is very simple code. So one thing for sure, I need to maintain. So this is by nums dot length, right? So definitely I am going to have a result array of same length. Then what is our job? It's time for us to start from index 2n minus 1, because this is what the imaginary array concept. So we will have index greater than or equal to 0 and index minus minus, and we are also maintaining the stack. Okay, so we are also having stack. Now let's move on. What is our job? So as long as your stack is not empty, and whatever value you have on the stack, if it is less than or equal to current value. So how do you know the current value? So nums of index percentile by n. Okay, so hope you understood, right? Clear now? Because we are starting from 2n minus 1, then we just index percentile by n. Perfect. So you will just delete it. Now it's time for to capture. So when do you capture? So as long as your index is less than n, then it's time to capture the result. So that result of index is equal. If the stack is empty, definitely it is going to be -1. Otherwise you will pick that whatever top value you have on the stacks, that is your value, and simply you will just push the current value into the stack. So this is going to be index percentile by, yeah, okay. So if you want to avoid duplicate code, you can store in one variable and return it. So finally this is our result. Code is clear? Is there any mistake with it? Why it is taking long time? Is there any issue with the internet, or let's see. Let me refresh. Yeah, it was succeeded. Array. What's happening? Is the internet is low or what?
I think it's fine, I don't see any lag. For the video and the
This
video.
submission, yeah, it got submitted. Okay. Alright, next problem is quite interesting, but I want to hear from you. How do you trying to solve it? Uh, if I get a right algorithm, then I can skip it. Otherwise, I'll explain it. So we need to remove top k elements from a given string and return the smallest string. So let me explain here. Or can we have session tomorrow, or do you need to practice? Do you want to practice? Except Akash and Kalyan, others can reply. Akash, Kalyan definitely says no.
I think we can have it. Anyway, Sunday is a break, so.
How do you see, Maithili? You need practice time, or it's fine?
Practice time, Srini.
Okay, then 1 and 1. So okay, so I'll give. Those two votes are invalid. So 1 and 1. Okay, fine. So you can practice tomorrow. But let me explain this so that you will get full-fledged problems for tomorrow. What I'm trying to say is, if you are able to solve these stack problems, right, then later we will learn queue problems. While learning queue problems, we will also solve breadth first search with dynamic programming, sliding window, lot of things. So it means if you are able to solve these problems, you are able to cover a lot of concepts indirectly, so that when we get into really graphs or trees, advanced concepts, then we don't need to spend much time. So better you take good time and practice. So let's move here. So what the problem statement saying? So you will be given a string. You will be given a string. Let me take it. So which is 143. Yeah, there is a lag in the writing. Let's see. If I remove it, recording will disturb. Let's bear today. So you are also giving k equal 3. So we need to remove 3 elements from the given string and return the smallest integer string. So if you closely see, if you remove these 3 elements, let's say if you remove last 3 elements, then what is the string you could get? 1432. Let's say if I remove last 3 elements, then it is 1439. And let's say if I remove first 3 elements, so it is going to be something like this.
1219.
Let's say I deleted this, so then you got this. Then what we deleted this, then it is going to be 13. Perfect. So then we delete these 3 elements, then it is 1419. Then let's delete
Why we can't delete 2, right? 1 to 1 it will.
I deleted these three. So 1419, right?
No,
And
4 is greater than 1.
array, see the possibilities. We'll come to the solution later. I want to see all possible solutions. Let's delete whatever you want. Whatever possible threes you can delete. Okay. 1419 and delete these three and 2219. So if you see, we deleted 333 elements in an sample deletion, and somehow I find out this is the smallest one, right? Yes or nobody? 1219 is the smallest
Yes.
one, right? So this is to be written 1219. How do you do that?
Srinu, three digits should be, I mean, the three digits should be consecutive, is it?
No, it can be anything.
Okay.
It can be anything. Yeah,
I mean,
it should be continuous.
it is
It's not like
consecutive.
it's
Yeah,
not
yeah.
like random. First I delete
Yeah.
3, then I delete 4, then I delete 9. Or if you delete 439, if I delete 439, then what is the result I got? Is it consecutive? What is trying to say?
We can delete 1 by 1, right? If the next digit is greater than 1.
It didn't say any constraints. Smallest possible integer after removing k digits from number. Your ask is, if I delete 439, it is going to be 1221. So that's I think it should be continuous. It should be continuous because he is also giving the same answer, right? 1219.
Yeah, that's okay because 1221 is greater than 1219. That's okay, but generally asking, like, is that constraint
That is
mentioned?
greater. Okay,
We can
then as he is not mentioning, then yeah, we can delete any number.
we can delete anything. Okay,
Yeah.
got.
Yeah, I thought I didn't read that 1219. Yeah. You know what happened yesterday? We were discussing about this next smallest element, and I am explaining algorithm for next largest element. And later we realized I explained wrong algorithm. If you were there now, you could have pointed that. So we missed you yesterday. Okay, so tell me, how do you solve it? It can be any large element. So he didn't mention any constraint, right? It can be any large element.
We can compare the first digit with the next one. If the next digit is greater than first one, so we will remove the next.
We'll remove which one?
So
First of all, uh, yeah, I'll get your. I got your thought. First of all, if I delete 439, these are the largest elements, but I got 1221, which is still larger than this. How do you confirm that? So one thing for sure, I should not randomly pick up largest elements and delete.
not like that. So we can try that one by
I
one.
understand your thought. Before going to that, can you tell me why? How do you confirm that this number is always smaller than this number, even you pick up largest elements? If you go in sequence,
Yeah.
it always be valid result. But before getting into that, if I try to delete large elements, that's a brute force thought we generally get, right?
But same numbers will be there in the middle, right?
It's all about
That
places, right? It's all about places. It is at one place, but it is somewhat at largest place, right? So, for example, you have 109. This is having thousandth place. This is having month place. Definitely, it is higher value. Correct, na?
Right?
Correct, Ajay, Maithili, Kalyan.
Yes.
So definitely, you should not pick based on the greater number. Okay. Now, how do you solve it? How do you solve it? Yeah, now you tell me, Akash. You come up with some thought. I think that works out. Can you explain?
So first, 4 is greater than 1, right? We can remove 4.
Mm-hmm. Then we can remove 4.
We can remove 3 also, right? 3 is greater than 2.
Okay. Then you have 1 only. Okay. Then
Uh, then 2 is greater than 1.
mm,
Then you can remove 2 also.
let me come up
Then
with
1,
good
1.
algorithm. Yeah, I got your thought. I feel that is not correct. But how do you, this case size is right? This case size is, let's say k equal to 1.
We need to remove. Okay.
Then in that case 4 will remain same, right? Yeah, your thought process is correct. So whatever thought Akash is suggesting, that is correct, but we need a little optimization on that algorithm. Can you think of algorithm, Ajay or Maithili? One thing for sure, right? I have delete higher position values, but which value should be deleted is the part here. I have to delete higher place values, not the actual values. These are in higher place, right? I have to delete higher place values with respect to k, and which higher place value to be deleted is the question. Please.
The higher
For
place
example,
value
yeah, just a minute. For
compared.
example, you have 4 and 3. We want to keep one of the value into the position. Let's say x is the higher position. We want to place one of the value into that x position. Which value you keep? 3 or 4?
I keep 3.
Correct. But you come to 3 when? After 4 only, right? You come to 3 after
Yes.
4 only, right? So it means
Yes.
in the stack, whatever top element you have, if it is greater than current element, delete it. That doesn't deserve this place. Correct, na? Ajay, Maithili. Correct.
Yeah.
That's it,
Yeah,
na?
if you are coming from left to right.
Yes, that's it. That's how you always come
Yeah.
from left to right only. So let me walk through algorithm. Now you
Okay.
have you have one. Okay, so stack will have one. K is 2, 3 only. Now you come to 4. And okay, so whatever previous value which is not larger than current value, so that keep 4 in the stack. Okay, now let's move on to next index 3. You come to 3. Now in the stack top value is 4, right? In the stack top value is 4, current value is 3, which is smaller than 4. So definitely this position can be replaced with 3. Correct or not?
Yes.
Ajay Maithili. Ajay Maithili, is that clear?
Yeah.
So as you deleted one value, decrement the k by 1. So k is 2 now. Now I am at 2th position. I am at index 2. Sorry, I am at this position. So current, if you see whatever value, current value is 2. The position you have 3. In the position you have 3. So this value can be replaced with 3 because current value is smaller than 3. So delete this, place 2 now. Okay, this is very critical observation. So if you get this observation done, so there is nothing in it, so you keep 2. Now you deleted one more element, so k becomes 1. Now go further, 2. Now if you closely see 2, right? So it means the current value is not greater than greater than or equal to.
Yeah, that is correct only. So we compare with the next value, right? So
I
we
understand.
add
No,
that
no, can I
value.
delete this or not? I'm just thinking of it.
We'll keep that value.
Okay, as it is not greater, so let's keep it. Now let's move on to 1. Okay, perfect. So when you are at 1, now current value is less than the top value, so that delete it. Delete it, place
You
1.
can remove that.
Then
Yeah.
this is going to be 0. Now I am at 9. Now if you see current value greater than this, but your k is 0, right? So that you should not delete previous value. Okay, even
Yes.
previous value is larger also, you should not delete it. So this is what you have. So you have 9, 1, 2, 1 in the stack. So just take those values, return in reverse. So 1, 2, 1, 9. So this is your expected answer. Clear, buddy?
Yes.
But one important edge case these people talking about is, let's say you have 10200, 10200 and k equal to 1. Okay, so now what will happen now? What will happen? So you have initially 1 in the stack, then current value is going to be 0. So 0 is smaller than this, so that you delete it and replace 0, and k becomes 0, and remaining values as used. Now if you reverse it, then it is going to be what? 0200. Then we should remove this leading zeros. We should return 200. Okay, but only problem is expecting the result in the form of string. Is expecting results in the form of string, so that if it is in the form of integer, this will auto delete, but he is expecting in the form of string. So that's what he is saying, right? So we need to return 200. What do you say? Preceding zeros should be removed from the result string. Is that clear, Ajay, Maitri? Now the problem is, if you see, the length of a given string is 10 to the power 5. So it's not like you can take any long or long value. You can't hold that value, because the length of a given string is, let's say given string length is 10 to the power 5. Okay, and k equal to 1, then you just delete only one element, and 10 to the power 4, if you want to convert that 10 to the power 4 into an integer, then you will reconvert into string. There is no data type which can fold 10 to the power 4 value. So that's why somehow you should handle this through strings only. Before going to there, so can you tell me what is the time complexity?
It's an
Ajay?
Big of n.
Yeah, it's a big of
n
only.
into k. Or
Why
n?
k, man?
What about the
Why k?
stack push operations?
Yeah, is it okay? Even how many times each element can be visited from the stack?
each digit will be pushed, right?
So let's say you have n equal to 5, k equal to 4. Okay,
Okay.
n equal to 5, k equal to 4. Obviously, 4 elements you will add to the stack, and 4 elements can be removed from the stack, correct?
Yes.
So of course it is
Yes.
into 2n only, right? Each element can be visited at max twice, sorry, at max twice. 1 through n, 1 through k, correct?
Yes.
So the time complexity is 2n, right? Maithili, is that clear?
Yeah, I forgot the stack operation actually. Yeah.
Yeah, so it's not n into k, Kalyan, it is 2n.
Though the k is equals to n also, it will be same. It doesn't matter.
Doesn't matter, right? You just do the operation from the stack, na? That always take constant time, and once you delete from the stack, you cannot revisit again, right? The same element.
Yes.
So definitely it's not multiple. And what is the space complexity?
We are storing k elements.
N elements.
Yeah,
Math.
yeah. You can say n, or you can say n elements, right? So let's say you have 10 to the power 5 and k equal to 1, then you will have 10 to the power 5 minus 1 elements in the stack.
Yes.
So
Yes.
definitely it is going to be linear. Okay, so be more clear about time and space complexity. Don't go in hurry burry, because there, yeah, things will go bad. Okay, so now the only challenging part is, okay, while writing the code I'll explain. First let me handle this. Definitely you are going to have stack. Let's say I have integers, because greater I can easily compare with the integer, or you can compare with the character also. Let's go with character. Character greater works. Yeah, it works. it's not. Yeah, so you have the characters. Let me check. So you have stack, because he is giving in the form of string now, so that's a tricky part. So let me do that. So you will have stack, then you will have integer index 0, index less than nums dot length, and index plus plus, and you will get character current number. If you want to be more clear, so let's take it as integer. Even character also it will work. So you can say s dot caret, not s, it is num, right? So num dot caret of index. So definitely it will return the character, and you just do -0, it will convert into integer. Now you have current number, and now see here, as long as if your k is greater than 0 and your stack is not empty, and whatever value you have on the stack, if it is greater than the current number, so definitely that doesn't deserves the place. So definitely you can remove from that value from the stack. As you remove, so just update the k value, so k minus minus, done. And finally you can keep the current value into the stack. So this is clear, na? Correct? Till now it's clear, right? So now it's time for us to build it. So one more part is let's say one edge case. So this is what the edge case. Let's say you have 324. Okay, 321. So let's say you have 321 and k equal to 1. Okay, so in that case, which value to be removed?
3.
Okay, so let's go. No, 3 obviously will remove. 123, k equal to 1.
2 will be removed.
In this case, which value to be removed to get the smallest value? 3, right?
3 again, 3
3 again,
again.
right? But our algorithm, how it works? So initially 1 will be there, 1 is smaller than 2, so that 2 will be there, 2 is smaller than 3, so 3 will be there. So it means our algorithm doesn't delete any element, correct? K will still remains 1, correct? As per our algorithm, if the top element is greater than current number, then only we delete and update the k, right? So in this case, top element is not greater than k, right? Yes or no, please?
Yes.
Maitri, is that clear, Akash?
No, it's not clear.
Array, you forgot the algorithm, buddy. So
No,
no, what are we trying to do? Whenever we delete the element, if the top element, whatever present in the stack, if it is greater than current number, then only we delete. So when we process 1, so stack is empty, so that 1 will present. When we process 2, top element in the stack is not greater than 2, so that 2 will be there. When we process 3, top element is not greater than 3, so 3 will be there. Stack contains 1, 2, 3 and k remains same, correct?
okay.
Oh, sorry, I didn't share this. So this is how it should be, right?
Yeah, I understood.
So k remains same. That's why what you should do. So in that case, what you should do, you will have to delete the latest. It means top values will always be. So it means if your k is greater than 0, it means the top values are invalid values. So that you just remove the top values and k minus minus. Correct? Correct, na? Yeah. Now it's time for us to build the response. This is very critical part. Do you want to do with if you want to do with something, one blind thought how it works? If this is the case, definitely what will happen, if this will be removed, so you will get 2 and 1. So definitely what you do, you will have a result which is starting from 0, and this is at 1th place obviously. Once you reverse it, right, so this is how it, right? So the top element is at 1th place and second top element is at 10th place. So our logic is what? Result into current element into place initially start from 1, then it is going to be 2, so result will be 2. And then second element equal result plus equal current element, so into current element is 2, and place earlier 1, it becomes 10, so earlier result is 2, 2 plus 10, so which is going to be 12, so result will have 12. So some kind of logic, right? So some kind of brute force logic you can do. So this is what it is, right? Hope you are able to understand now. So initially place is starting from 1, and you will just multiply the place value and add to that current value into place value plus result, you will get the result. So that's a brute force logic, but the problem is here here you have 10 to the power of 5 values. So how do you hold that value into result? It is very complex, correct na Maithili?
Yeah.
So then how do you solve it? So that's where I will just use a concept of string builder. So I will just use new string builder. So what I'll do, in simple, whatever value you have, you will append to the stack. So there are one tricky logic I will tell. If you pop it from the stack, right? So let's say this is this is not this is not conceptual logic, but let me explain so that you can hack the code. So when you pop it, you always get the top elements. But if you iterate from the stack, right? So somehow if you iterate from the stack, it always load from the first element. So you will get 1, 2, 3 only. If you iterate the stack, if you pop the stack, then you will get 1, 2, 3, 3, 2, 1. But if you iterate the stack, you can simply get 1, 2, 3. So I think you did it in most of the times in the code, right? So because when you try to iterate, so it will load into iterator object, and somehow it will get it, because stack they build from linked list only, no? So when you iterate, it will start from head, or if you try to pop it, it will start from tail. So it's a concept of same. So what I'll do, I'm trying to iterate the stack. Okay, just in the stack I'll have a number. I'll just try to iterate the stack so that it always comes from the front. So it always comes from the front, so that sp dot append of number. Is that clear, buddy? Ajay? So that you don't need to reverse it. So once you get the number, what is happening, you need to delete the starting zeros, right? So let's say as long as your string builder length is greater than 1, so if it is empty, you obviously return 0, so that as long as length is 1, and whatever character present at 0th index, if it is equal to 0, then you need to delete them, whatever you have at first position. So delete caret 0, so you keep on delete that unless it becomes empty. So once you get the result, so just return sb dot toString. That's it. Is that clear? So this is for leading zeros. For example, you have input you get something result 22200, then you have to delete first two zeros. That's it. So you can return that string. Okay, what is happening? E is expecting E is expecting empty, but we are returning I understood it. Where is it? So cake. Yeah. So how do you address this? How do you address this?
sb dot length.
Perfect, right? So it's a base case which is failing. If you closely see, if whatever num dot length length which is equal to k, then you can simply return empty string. Okay, so that's a base case.
No, not there actually.
Here num length is 2, k is also 2, so we just need to return. Okay, output is empty, but expected is 0, right? Okay, so in this case we return 0. That's it. So successfully we completed stack problems, and please spend a good amount of time this weekend. You will definitely be confident in that. How are the problems, Ajay?
Really good problems, like yesterday I was able to complete it. So
Mhm.
yeah, need to check for the remaining ones. Yeah.
But the Q problems also really nice. So let's see if you follow this pattern right, definitely we'll be very confident. Okay, and stop